Alright, today 10.5 recursion and iteration. It looks very scary, I know that. It's actually not. When we do these, a recursive sequence, each term is determined by one or more previous terms. So what that means is, for example, Fibonacci sequence is a pretty popular one. If you look, the first term is 1, and then it's a 1. Well, 1 plus 1 gives me 2. 2 plus 1 gives me 3. 3 plus 2 gives, do you see how you're using the one before it to get the next one? Okay, that's basically what recursive means, all right? So, it's not hard, but if you screw up any of those numbers, then the rest of it's wrong. So you just have to be really careful, okay? Recursive formulas, you have arithmetic and geometric. They are not on your formula sheet. I'll get to why later, but typically we have to come up with our own anyway. Or is it on there? Oh, it is. Just kidding. I thought last class said it wasn't. Okay, never mind. Doesn't matter. Arithmetic is a sub n equals a sub n minus 1 plus d. Geometric is a sub n equals r times a sub n minus 1. A sub n is still a sub n. That doesn't change, okay? R is still R, D is still D. Those still mean the same things from before, common difference, common ratio. This time, a sub n minus 1, what that means is the term before it, okay? So if I'm talking about, for example, this sequence again, if I want the third one, okay, then a sub 3 is what I'm looking for. Does that make sense? So then I would plug in, even though this isn't really for this, by the way, then I would plug in 3 minus 1 is 2. It means, hey, take the second term and add the common difference back in. If that doesn't make sense, it's okay. We'll do some more, all right? Iteration, I don't even want to talk about just yet because it looks super scary, but it's the process of repeatedly composing a function with itself. So again, you're going to get an answer and use that to get the next one is basically what that means, but we'll come back to it later. So number 16, find the first 5 terms of each sequence described. So I wrote these up somewhere else so that way I'd have more space because I ran out pretty quickly. So they said the first 5 terms, so 1, 2, 3, 4, 5. That's how I start, okay? From your quiz yesterday, a lot of you guys didn't realize if they give you a sub 1, then they already gave you your first term, right? So go ahead and put that in there. You don't need any more, right? So a lot of people like kind of, I guess, I don't know if you forgot it or what, but then you added an extra blank. Does that make sense? So don't do that, okay? If they want the first 5, put 5 blanks. A sub 1 goes into your first blank. Is that okay? Whenever we do these recursive formulas, you have to have the first term or else you don't know what to do. So if I'm using something before it to get the next one, they have to tell me where to start. Does that make sense? You can't start from nothing, okay? So this 6 goes here, and then we need a sub 2, 3, 4, 5, whatever. So I'm going to rewrite the formula, okay? And the back of your notes are blank, so if you run out of space, you could always go back there if you need to. You okay? All right, see you later. Thanks. So if we want a sub 2, if I were you, maybe just watch me for these first couple. It's totally up to you. If you want to write it down, that's fine. I'm not going to yell at you or something. But it's a little bit hard to watch and write, I think. So maybe just watch me. So if I'm looking for a sub 2, does everybody understand that's what I want? I want the second term, right? Before today, it was really easy. This said a sub n, so n was 2, wasn't it? But today it doesn't say a sub n. It says a sub n plus 1. So if I'm looking for a sub 2, then what's n? Nope. N is 1 here. So literally, n plus 1 and 2 are in the same spot, right? So it means they're the same. So what is n? 1. Do you guys get that this is the same as 1 plus 1? This is the same as this? So n is 1? Okay. So 3 times a sub 1 minus 1. I'm going to say it again. You can start writing if you want to, okay? If I'm looking for a sub 2, then I want this to be a 2. To make this a 2, what do I have to add to the 1 that's already there? 1. Do you get that? So n is 1, even though I'm on the second term. It's the way that they wrote it that makes n a 1. So, going back to the formula, it's going to be 3 times a sub 1 minus 1, because n was 1. Is that kind of okay? Okay? So, what is a sub 1? 6. So what's 3 times 6? 18 minus the 1, 17. So our second term, a sub 2, is 17. Are you kind of okay? Okay. Let's try the third term, a sub 3. So again, if it's a sub n plus 1, what does n have to be for that to be a 3? 2. So I'm going to do this again. 3 times a sub 2 minus 2. Do you get that? So what is a sub 2? 17. So 3 times 17 minus 2 is 49. Our third term is 49. I'm going to pause. Some of you are algebraic. If you're algebraic, just keep doing what I'm doing. Some of you are more geometric and you understand patterns and you see them easily. Awesome. I'm impressed because I'm not. Patterns are very hard for me. I'm more algebraic. I like to follow a rule and just keep doing it. But by now, I'm thinking most of you notice, you take 3 times the answer you just got minus this next one would be 3, right? So if you get the pattern, a sub 4 is going to be 3 times 49 minus 3, which is 144. And then a sub 5 is going to be 3 times 144 minus 4, which is 428. I did half the problem one way, I did half the problem a different way. One of those should feel a little bit more comfortable to you. Okay? So if you're a formula person, great. Do that every time. If you're a pattern person, do it a couple times till you figure out what the pattern means, and then you can just plug it in. Is that okay? We found the first 5 terms. That's all they wanted. Does anybody want me to go back and finish it a way that I didn't? Like do the front half a different way or the second half a different way? You sure? Okay. Okay, let's try the next one. Anyone still need that? All right. Same thing. Find the first 5 terms again. So 1, 2, 3, 4. I ran out of room, so I'll put 5 here. First 5 terms. What is a sub 1? 2. What is a sub 2? X plus 3. Okay, we only have to find 3. That's awesome. Do you guys get that? There's nothing to solve. They told me what they were. Okay? So to find a sub 3, I'm going to go ahead and write my formula again. I like to have it right above what I'm doing. Okay? If I want a sub 3, what's n? 3. This time it said a sub n. So literally, n is 3. Do you guys see that? The last time it had like n minus 1 or something. So we had to kind of think about it. But here it's just n. A sub n and a sub 3. N is 3. Is that okay? Aaliyah, do you see it? Yeah. Okay. So a sub 3 minus 1 plus 6 a sub 3 minus 2. I literally just put all those n's as 3's. Okay? So that's a sub 2 plus 6 a sub 1. Do you guys understand that? Okay? So what is our second term? We know what a sub 2 is. What is it? X plus 3. And a sub 1 is 2. I just plugged in what I know. Is that okay? So again, x plus 3 plus 12 is x plus 3 plus, x plus 15. Our third term is x plus 15. Ask me a question if I lost you. I'm going to do algebraic again, and then I'll do geometric where we just like talk about the pattern, okay? So if I want a sub 4, n is 4. So I'm going to say a sub, well, what's 4 minus 1? I don't have to write all that down. A sub 3 plus 6, a sub 2, because 4 minus 2 is 2. A sub 3 plus 6, a sub 2. So what's my third term? What's in the third blank? x plus 15 plus 6, what's in my second blank? X plus 3. Do you see how I'm literally just substituting? Okay? So x plus 15 plus 6x plus 18. Distribute, right? Combine like terms, what do you get? 7x plus 33 is my fourth term. Now I'm going to talk about the pattern. If you wanted a sub 5, you could totally just do this again, right? That's fine. The pattern says, if you're looking for like the fifth term, okay, you're going to take the one right before it, right? N minus 1 means, hey, the blank before it. So the fourth term for us, okay? Plus 6 times the one 2 blanks before it. Do you get that? So I'm going to take the one before it, so the fifth term, is equal to the one before it, the 7x plus 33, plus 6 times 2 before it. So here's 1 before it. 2 before it is the x plus 15. Do you guys get that's what the pattern is saying to do? Okay? If not, plug in a 5 and do what we did on all the other ones. Doesn't matter, just pick away. So a sub 5 equals 7x plus 33 plus 6x plus 90. Is that right? So what do you get for your fifth term? 7 and 6 is 13x. 33 and 90 is 123. So 13x plus 123. Is anybody lost? Yeah. So here's our 5 terms. Oh, I don't know why I have a comma there because I ran out of space. That's my last term. Questions yet? You sure? Okay. So we're going to jump to number 33 next. The 26 and 30 are, in my opinion, the hardest. So we're going to do 33 next, okay? So find the first 3 iterates of each function for the given initial value. They gave me f of x and they gave me x sub 0. So if you go back to your first page, well, just kidding, you're on the first page. If you go back here, this is what we're doing. This is on the back of your formula sheet. I want you to look there too. Can you look on the back of your formula sheet where it says all this? Okay? Because that's what you're going to have. So make sure you know what it says. So this says the first iterate, okay, or the first blank is really kind of what they're saying, okay? The first iterate is f of x sub 0. The second is f of the answer you just got, f of x sub 0. The third is f of the answer you just got, f of x sub 0. That looks very confusing. I know that. But we're going to do it, and I'll show you it's not that terrible. So I'm going to do algebraic for half of them, and then pattern for the other half, okay? So x sub 1, literally it said, is equal to f of x sub 0. That is what your formula sheet tells you. Do you guys see that? So it said find the first 3 iterates. That means find the first 3 blanks, okay? So a lot of people in the last class asked me if x sub 0 went in the first blank. No, what goes in the first blank? X sub 1, okay? X sub 0 is just to help me get it started. Does that make sense? Okay? So the formula said x sub 1 is the same as f of x sub 0. If you go back a couple chapters, f of x, what did I replace x with? From here to here. Instead of an x, I put x sub 0. What is x sub 0? 4. They said it's 4. Right here. Right there. So I'm just substituting. I've done nothing fancy. In my function, instead of an x, I'm going to put a 4. So 12 times x plus 8. That is what x sub 1 is. What is 12 times 4? 48 plus 8, 56. So x sub 1 is 56. I'm going to say all that again, okay? it tells you your formula is x sub 1 equals f of x sub 0. X sub 0 is 4. So I'm really saying, hey, find f of 4. F of 4 means go to your f function, which is this guy, and replace all the x's with 4's. So 12 times 4 plus 8 is 56. My first term is 56. So again, your formula says x sub 2 equals f of x sub 0. Well, lucky me, f of x plus 0, f of x sub 0 is 56, isn't it? We literally just said it, right? So now in my f function, which is 12x plus 8, what do I replace all the x's with? 56. So what's 12 times 56 plus 8? 680. Are you catching the pattern yet? What would we do for our third one without having to write anything down? Plug in 680. 12 times 680 plus 8 is 8,168. So I know how confusing that formula looks. Literally all you do every time if you want to is plug this guy in first, and his answer you plug in next, and his answer you plug in next. That's it. It's just substitution. But if you get any of them wrong, you messed up everything, right? So you have to be really careful. Does anyone have a question on that one? So the next one's the same thing. Find the first 3 iterates. 1, 2, 3. So on x1, I'm going to plug in what? 8. So what's negative 6 times 8 plus 3? Negative 45. What am I going to plug in for x sub 2? Negative 45. So negative 6 times negative 45 plus 3 is 273. And what do you get for your third one? Very good. Is anybody confused by that? Super easy now, right? So I want you to look at the formula on your formula sheet again and see how confusing it looks, but then just kind of like make the connection that all you had to do was plug in the last one to get the next one. Is that okay? Okay. All right. We're going to add a couple of questions on the back before we get to 26 and 30. We're going to do a couple on the back because they're a little bit easier before I get to the harder ones. So on the back, let's write this one down. You don't need a ton of space. We're just going to do like 3 of them. So that says 2A if you care. Okay. So the list is 2, 10, 18, 26, 34. Okay. So I think the question would say, write a formula for the recursive sequence or something like that. So the first question we have to ask ourselves, is this arithmetic or geometric? So take a second and see which one you think it is. Are we adding the same thing every time, or are we multiplying the same thing every time? We're adding. So this is arithmetic, and D, the common difference is 8. Is everybody comfortable with that? So when it's like this, where it's straight arithmetic or straight geometric, we can use the formula from the front of your sheet, or it's also on your note sheet. So if we said arithmetic, this is a recursive sequence, so it's going to be a sub n equals a sub n minus 1 plus d. That's the formula from either sheet. Is that okay? Where, just like before, you have to give me a sub 1 and d. So a sub n equals a sub n minus 1 plus 8, where a sub 1 is 2. That's it. It's just like before, where you had to give me a sub 1 and d, but here you just plug in d for the formula, and then you say, hey, by the way, a sub 1 is 2. Because when it's recursive, if you don't give me a starting point, I can't do it, because it always uses the 1 or 2 before it, basically. So if you don't give me a sub 1, I have no idea where you're starting. Does that make sense? Okay. Did I lose anybody? Okay. Anybody still need it? 2B, 16, 56, 196, 686, 2401. Figure out if it's arithmetic or geometric. what is it? Geometric, where R is, yeah, 3.5, same thing. Either way. So I'm going to use that formula. It's A sub n equals R times A sub n minus 1. So A sub n equals, I'm going to say 3.5, but it doesn't matter, 3.5 times A sub n minus 1, where A sub 1 is 16. That's it. Have I lost anybody? Okay, great. One more on the back here. Does anyone still need it? Just don't forget, you have to give me A sub 1. If you don't give me A sub 1, I don't know where to start. Okay? Because this could have, I don't know mathematically, but this could have started at like -2 or something. So you have to give me A sub 1 so I know where you're starting to count from. Okay? Okay. 2C, A sub 4 is 108, R is 3. So obviously it's geometric because they said R, right? So we're going to use our A sub n equals R times A sub n minus 1 formula, where A sub 1 is, I don't know. Does that make sense? So I know A sub n equals 3 times A sub n minus 1, where A sub 1 is, I'm going to find that out in a second. So everybody understand I have everything but A sub 1. Okay? I could go back to the front of my formula sheet and find A sub 1 that way. Or if it's the fourth term, couldn't I just like go backwards? You know what I mean? So we can go back and use that formula if you want to. But I'm just going to figure it out this way because that's not that hard. Okay? If it was hard, if it was like A sub 100, you would go back to your geometric formula from the front, plug everything in, and that's how you'd find A sub 1. Okay? So if R is 3, what am I going to do to go backwards? Divide by 3. So what's this one right here? 36, and then 12, and then 4. So A sub 1 is 4. Have I lost anybody? Are you sure? Super easy? Okay. These last two, we're back on the front now when you're ready. For these, it said something like, write a recursive formula for each sequence. These two, you can just look at and know pretty quickly that they're not arithmetic and they're not geometric. You can tell that pretty quickly. Okay? You could try, like you'd want to check, but they're not. So what that means is that that last number is 50,175, by the way. This is one number together, not a comma. Okay? So with this, it's not what we did on the back. It's not that easy. I literally have to come up with one on my own. There is no formula to give you. You have to figure it out on your own. So this is kind of like, don't freak out when I say the word, but this is kind of like proofs in geometry where I can't really teach you how to do it. You know what I mean? I can give you tips and I can give you tricks, and some of them you're going to get and you're not going to need any help, and some of them, it doesn't matter how long I give you, you're never going to get that one. Does that make sense to you? You either see the pattern or you don't. Okay? So the best advice I can give is get out your calculator, okay? And you just start punching numbers. So these are going to look like number 16 and 22 did. They're going to be something like that, where you have to find the formula. You have to be like, okay, take the one before it times 3 and add 7. Or take the one before it squared plus 15. Or take the 2 before it, divide by 5, add 6. I don't know either, okay? So you have to look at it and start playing with your calculator until you find something that works. So I would partner up and start punching buttons in your calculator and see if you can find a pattern. I'm not asking you to write it down yet because that's the hard part, I feel like. Just start playing with your calculator until something makes sense to you. And give everybody a second if you think you've already found it. Unless you punch buttons on your calculator, it's never going to work. You can't like do it in your head. It's not going to work out. I'm going to let you in a little secret. I'm not perfect. These were always very hard for me. I don't say that to make it okay that it's hard for you, and I don't say that to make you think it's harder than it is. I say that to say you either have a brain that works with patterns or you don't. So you just do the best that you can, okay? Does anyone think you found the pattern? It doesn't have to be pretty. Just what do you think you found, Eli? So then about squared and minus 1. Okay, so let's look at that together. You square the one before it, minus 1, right? So what's 4 squared? 16 minus 1, 15. What's 15 squared? 225 minus 1, 224. 224 squared minus 1 is that. Okay, so here's where the really hard part is writing it down. There's more than one way to do it. That's why I said it's like proofs again. Just because I wrote it this way doesn't mean it's the only way to write it down. Okay, so I'm going to write down what I have. So I have a sub n plus 1, because those make more sense to me. So a sub n plus 1 equals the one before it squared minus 1, where a sub 1 is 4. And I'll walk you through what that says in a second. So I'm saying, hey, if you want the next term, n plus 1 would give me the next term. If n minus 1 is the term before me, n plus 1 is the term after me. Does that make sense to you? Okay? So if you want the next term, take the one before it, because if I said n plus 1, then just an n is the one before it, right? Take the one before it squared minus 1. And if you want to make sure it really makes sense, you could plug it in, right? You could say like a sub 2, n would be a 1, means take a sub 1 squared minus 1. Well, that's true. Okay? Again, it's not the only way to write it. That's just what I did. But make sure you always give them a starting point, which is a sub 1. Try the next one. Just take a minute or two and try to figure out a pattern. That's the hardest part. Just find a pattern. Push buttons on your calculator until something looks somewhat like this. You think you found it, or you just think staring's going to work? You know you got it. Okay. I always find this interesting because typically I can, after I've had you in geometry, I can typically tell which left brain, right brain you are. You know what I mean? And so, like, I knew Bradley would be good at these. You know what I mean? I knew Eli would be good at these. You seem to have, like, a figured out kind of brain. Ben, I'm assuming you're good at these. Kind of. If you're awake, I saw you fall asleep a little bit. You got this one. Okay. Bradley, go ahead. Yeah, something like that, right? Take the one before it, divide by 3, and add 1. So if you want to actually check it, right, we would take this divided by 3, add 1, this divided by 3, add 1, this divided by 3, right? So the hard part, again, in my opinion, is writing that down. And there's more than one way to do it. So I'm going to say a sub n plus 1 again. I'm saying, hey, to get the next term, do this. So if I want the next term, I'm going to say 1/3 a sub n. You guys get that's the same as divide by 3, right? You could have said a sub n over 3 instead. And then you said add 1, where a sub 1 is 393. Yes, yeah, either way. an over 3 is fine. It's the same thing. Technically, you could have written a sub n divided by 3 plus 1. That's fine too, because PEMDAS would work that out for you. Okay? So if those are really hard for you, we're just going to do the best we can and we're going to practice. I can't force your brain to think differently than it does. I can help you. I can help you practice. I can help you find tips and tricks, but every question is different. So just because these two maybe were hard for you doesn't mean you can't do them at all. There's going to be some that you are going to see right away before your friend does. There's going to be some that they're just going to have to tell you how to do it. Okay? So I wish there was a better way to tell you than that, but there's really not. You either see the pattern on that question or you don't. Okay? That's it. So you guys have your homework. Answers are in the binder. I do not have a homework quiz made for this tomorrow, so I am going to check your homework tomorrow. Okay? Curiosity.